Good afternoon. I'm Ken Appel with NASA Communications here at Kennedy Space Center in Florida. And welcome to the CRS-21 NASA Social Science and Station Q&A show, where you can ask questions to our participating science, research, and commercial mission partners here today with us. SpaceX is preparing to launch their upgraded cargo Dragon spacecraft for the first time, filled with tons of supplies, 6,400 pounds to be exact, and it's not all holiday food, although some is. It's mainly supplies, tools, research, science for not only NASA, but academia, as well as other government organizations and even commercial partners. So for today's show, we're going to dive into how the station is a cutting-edge laboratory and how it's evolved into a catalyst for a low Earth orbit economy. Now, CRS-21 stands for Commercial Resupply Services Mission to the International Space Station for NASA. Now, CRS-21, it is SpaceX's 21st cargo resupply mission for NASA, but that does not mean that this mission doesn't come without many unique firsts. Let's get started with an overview of today's show. We are going to chat with guests from station, science, and the commercial sides of this mission. You'll have the chance to ask them questions after their introductions. So first, from the station side, we're going to speak with Jennifer Scott Williams, joining us from the ISS Program Research Office in Houston, Texas, where NASA's Johnson Space Center is located. Then we're going to head over to the commercial side, and here back in the room with me at Kennedy, we have Brock Howe from Nanoracks. And then heading back virtually, we are going to talk science with Pinar Messi. She is from the experiment heading to station that is studying brain organoids. So now let's virtually meet these guests that are here to answer your questions. There are 3 ways that you can submit questions. If you're watching on YouTube, you can just submit a comment with the question. If you are a part of our virtual NASA Social Facebook page, you can submit questions there, or you can go to Twitter and use the hashtag AskNASA. So first, we're going to virtually head to Texas to hear from Jennifer Scott Williams. So Jennifer, we just celebrated 20 years of continuous human presence on station, which I find amazing that some folks watching today may have never lived on Earth with every other human being at the same time. Can you tell us a little bit of how you've seen the station evolve, and of course, tell us about your role?
All right, well, thank you for that question, Kenna. First, let's reflect on that number, 20 years, right? Think about where you were 20 years ago, if you were here, and consider that students that are graduating from high school this year have always known a continuous human presence in space. So the ISS started off as an idea, right? And so from there, it grew to a concept and then evolved into an international engineering feat. So it grew from 2 simple modules in 1998, the Russian Zarya and the American Unity modules, and then over 135 shuttle missions and cargo flights later, we have the ISS we see today. And with a length of a football field from end to end and the habitable volume of a 5-bedroom house, we've since designated the station as a world-class orbiting microgravity national laboratory, where we've conducted over 3,100 science experiments on board. So my role, I'm in charge of the team responsible for enabling technology demonstrations, STEM experiments, external investigations and platforms, which are things that fly outside the ISS, and some of our commercial activities as well. We ensure that from kickoff or concept to touchdown, return of data, samples, hardware, whatever you need to the ground, we make sure that these experiments have the funding, the support, and the assistance needed to be completed successfully on the ISS.
Jennifer, thank you. Now back here at Kennedy with me, I have Brock Howe in the room. He is the program manager of the first ever commercially funded and operated airlock heading to station tomorrow. So Brock, simply put, what is an airlock? And you have this super cool model of Bishop. Can you walk us through it?
Sure, thanks, Kenna. I appreciate it. And yeah, the Bishop Airlock is going to be the brand new module for the International Space Station, and it'll be commercially owned and operated by Nanoracks, our company, and we're really excited about bringing this capability to the space station. Now, the airlock is not science per se that we're going to hear about later on this afternoon, but rather an enabling technology to allow scientists to have capabilities and features that they've never had before on the ISS, capturing on Jennifer's discussion about 20 years of a world-class laboratory in space. What I think is really neat about it is it continues to evolve and expand. And so we're continuing to expand that science and giving those scientists and crew capabilities that they've never seen before. So we'll continue to grow that. Nanoracks is really proud to be part of that and expand it in a way that's commercial in nature. So what is the airlock? Airlock really in general simple terms is a way to get equipment and people from the inside of the space station to the outside. It's like a doorway to space. So here's your doorway to space. The Bishop Airlock is going to be provide a really large door that we haven't seen before to get there to space. So if we capture in, as kind of mentioned before about the model here, so we have a 1/10 scale model of the Nanoracks Airlock. To give you a perspective of size of the airlock, Jennifer talked about a 5-bedroom house. What the airlock's going to bring is about a new office space volume to that International Space Station house of working area for the crew, working area for the scientists, and capabilities within the airlock to be able to support those kind of science activities. So let's talk about the airlock model a little bit itself. We got a crew member here, old school nature in the space world, crew member to help us kind of illustrate the size of the airlock. So the airlock itself is what we call a bell jar type design. So if I look at the airlock, it's kind of a shape like a bell jar like you might have done in chemistry or physics back in your school days. It's wide open on the inside. That's the area for the scientists and the experimenters to work in. Walking ourselves around the airlock and the structure. So the entire airlock is designed and built and tested by the Nanoracks team in Houston. But we have a lot of support that was going on throughout the design and build of this hardware. So for instance, the common berthing mechanism that you see here at the front, this is the device that will actually attach us to the space station. The little orange ring that you see around the sides, that's the seal that will seal us to the space station. The bolts that are 16 bolts that are lining that ring will actually bolt us to the space station itself as well. That's provided by our partners Boeing and Huntsville. And if we look at the inside, again, the inside is wide open, but we have avionics and electronics in the inside built by the Nanoracks team. The avionics allow us to interface with those experiments and give command and control capabilities for those experiments that are going inside the airlock. On the outside, kind of the airlock, again, forms the shape of the airlock. It's sized to fit in the Dragon trunk. It takes up the entire trunk of the SpaceX Dragon vehicle. On the outside, you'll notice a couple grapple fixtures on the outside. We're totally robotically controlled and operated by the space station robotic arm, and so those are used to handle the airlock on the outside. There's, of course, EVA handrails to support the crew members on that. There's Wi-Fi antennas to provide communications when we're out on the arm. There's also some external payload mounts on the outside that provide interfaces for external payloads as well, and those are provided by partners Oceaneering. The entire structure was built by Thales Alenia in Italy, and we have a host of other partners that are helping us out to get us here. So lots of people that are cheering us on for the launch tomorrow to get there. We're excited about that. Now, how do we use this as an airlock? So if you use an airlock, you need to transport the cargo and equipment into the airlock, and then it's transferred to the outside. So we'll use our crew member here. So after we get on board the space station, the crew member would open the hatch to node 3. They would then float into the airlock. You can kind of get a rough perspective of size with our crew member in there, install the equipment, and then they would close the hatch, and then the airlock would be depressurized and actually pulled off of the stack of the ISS by the robotic arm, go out and deploy satellites, maneuver equipment, and then come back to node 3, back to our home at node 3, and rebirth us there. I think they have a good picture online that shows kind of a relative size of the airlock. There it is. Just prior to berthing at node 3, you can see the hatches closed on node 3. That gives you a relative size of how big the airlock is with respect to the rest of the station modules. So we really look forward to this. This has really been a great experience. I'd be remiss if I don't give a shout out to NASA, our greatest partner probably of all of them, to fully embrace the commercial low Earth orbit effort and have faith in Nanoracks about 5 years ago to really think that we can really pull this off. And now here we are today, super excited about the launch. And really, again, thank you to NASA for helping us out along the way.
Thanks, Brock. And so for our viewers at home who may be familiar with the station, we already have 3 airlocks on the station. Can you explain what makes this one stand out and what special capabilities that it has?
Okay, great. Yeah, great question. Great question. Yeah, there's 3 airlocks on board the space station. There's 2 for EVA for the spacewalks, so 1 on the Russian segment, 1 on the U.S. segment. And then there's a cargo airlock inside the Kibo module on the Japanese experiment module. Nanoracks has been a frequent user of that airlock, but it's got a little bit limited capabilities. It can maneuver a payload about the size of a microwave. So we continue down that path of a house analogy where the Kibo airlock can handle something about the size of a microwave oven going outside. Now the new Bishop airlock will handle something about the size of a refrigerator. So if I use a little bit of the more models perspective, so that to scale, this is about as big as a piece of cargo that you can deliver to through the Kibo airlock right now. If I install that into the airlock, you might be able to see it within there. It's pretty small within the size of the airlock itself. Now, what that does is we can then have payloads that maybe on more of the size of what we see here. Again, refrigerator, freezer kind of size payloads, or multiples of these, which would save crew time. So we have a lot more capability now that there never has been before to be able to deploy things outside, maneuver equipment outside as well.
Awesome. So Jennifer, I wanted to bring you into this. I have a question. Why is it important for NASA to enable commercial activity like this?
Right. So NASA is opening the International Space Station for commercial business so industry can accelerate a thriving commercial economy in low Earth orbit. So we've already got more than 50 companies conducting commercial research and development on the space station via the ISS National Lab, and their results look very promising. NASA's worked with 10 different companies to install more than 14 commercial facilities, just like one that Brock is mentioning with the Nanoracks Airlock on station that support NASA and ISS National Lab initiatives. Now, because the ISS National Lab mandate is limited to research and development, there's a new NASA directive that enables commercial manufacturing and production and allow both NASA and private astronauts to conduct additional commercial activities on board the ISS. So this directive also sets prices for industry use of U.S. government resources on the space station for commercial and marketing activities. All of this allows NASA to fully focus on its goal of landing the first woman and next man on the moon by 2024. And there, we hope American companies will play an essential role in establishing a sustainable presence. So it's important for NASA to enable commercial activity on the ISS in order to, number one, get the government out of the way and allow space commerce industry to really take shape. And then also, two, to allow NASA to focus its resources on exploration.
Thanks, Jennifer, and thank you, Brock. So we've heard from the station and commercial sides of this mission, so now let's talk science. We are going to hear from Pinar Messi. She is from the effect of microgravity on Human Brain Organoids experiment, heading up to station tomorrow. So hey there and welcome for joining us. And can you tell us a bit more about what you're studying and why it's necessary to do this in microgravity.
Hi, Kenna. Thank you so much. And I'm very excited to be here. So basically at UC San Diego, we are studying the human brain, how it's developing. Do that by using what we call brain organoids. So brain organoids are three-dimensional structures that are obtained from most of the time human skin cells that go through a process that we call cellular reprogramming that makes them become stem cells. And from basically those stem cells, we can create virtually any cell type in the body. And here in the lab, since we're studying the human brain, we are making brain cells and these three-dimensional structures called brain organoids that are able to mimic both the cellular variety but also the function of a developing human brain. So why do we want to send them in the ISS? Because there's actually many reasons. First of all, there are actually no other way for us to study microgravity here on Earth. So that's one of the main reasons. The other reason that you might have about it before, it looks like long periods of time spent in space might lead to rapid aging. And this is actually an important feature for us to use and harness to make better models. Because as I was telling you, we are able to make these brain organoids, but these brain organoids are mainly mimicking the very early stages of the human brain development. So they might not be well suited to study diseases such as neurodegenerative diseases for which the age is the major risk factor. So by feature of spending time in space that leads to accelerated aging to make better human models to study those diseases as well. Another aspect of this study basically to provide an experimental model to see what is the impact of microgravity on, because so far we have heard we have had some studies, but we don't really have a mental model to really study what is going on at the cellular or molecular level. And then finally, of course, we would like to be prepared or be able to mitigate potential problems when we're going to have longer periods of time in space or for space travel or space colonization. So we want to be able to have as much information as we can, be able to mitigate those problems when the time comes.
Thank you. And now that we've heard from our station, science, and commercial representatives, we want to hear from you. Submit your questions on the YouTube stream in the comments, on Twitter using the hashtag AskNASA, or if you're part of our virtual NASA social Facebook group, you can ask questions there. So our first question comes from YouTube, and I think, Jennifer, this would be for you. With a larger crew on board, how many more experiments can get done?
Oh, that's a great question. So a larger crew on board is great for science. We have more team members that can be scheduled for critical activities to keep the station going, plus do all kinds of science experiments. Since we only had the crew one team on board for a short time, it's hard to give you an actual number, but we estimate that the additional crew time will allow us to more than double the amount of science that we've been able to do in the past. So we are so thrilled and so excited for science.
Thank you. And speaking of more crew members on board, I find it amazing that tomorrow, on launch day of this grocery and supplies haul, we actually just 3 weeks ago had astronauts launch from that very same pad. And like I just mentioned, they're the ones that are going to have to unload the grocery haul and supply haul. So I think that's really cool. So our next question, Brock, this is going to be for you, and it is, can we use the Bishop Airlock to get rid of some of the trash on the ISS?
So that's a great question too. So yeah, actually one of the very first uses of the airlock might be actually deploying trash off the space station. So we think a lot about the science that goes on with the space station, and it's a world-renowned national laboratory. But in order to do that science, sometimes you got to clean up your house a little bit, right? So you have to maintain a clean working environment. So one of the aspects of trash that's unique is that if you think about your trash at your house, so putting this kind of layman's term in our terms, your trash truck shows up maybe once a week, maybe twice a week. It becomes pretty regular, right? So, but for the space station, the cargo vehicles that are going to the station also act as the trash trucks coming back home. So that's maybe once every 2 months, 3 months, somewhere in there. That's a lot of trash to build up in your house when you're trying to do that. So one of the aspects of the Bishop Airlock, why it has a large capability, you know, again, we talk about 5 times the size of the Japanese airlock, is the ability to maybe get rid of trash. And so this is the model that we were talking about for the actual trash bag. It's a very large trash bag. We're talking about 600 pounds of trash, a little bit bigger than your trash can in your kitchen. So we're talking about a large amount of trash to be able to deploy out of the airlock. So this trash bag would fit inside of the airlock, and then would be deployed out of the airlock, and then would, just like any other kind of satellite deployment, it would eventually orbit the Earth. Eventually, orbit would degrade and it would burn up in the atmosphere. But that would allow the crew then to be able to remove that trash whenever they need to, rather than waiting for the next cargo vehicle to come get to them.
Thanks, Brock. Our next question, it comes from the virtual NASA social Facebook group, and it is for Pinar. Is it true that cells and tissues in the body age more quickly in space?
So this is actually a very good question. It looks like from the earlier and also the more recently the NASA twin study, it looks like there is indeed an accelerated aging, or signs of accelerated aging, such as shortening of these pieces of our chromosome called telomeres that are basically decreasing in size at each cellular division, and at one point when it's the critical size, they actually will go to die. So that's kind of like a way to see how fast they're aging. And this is actually some of the things that we're going to look into in our brain organoids to see if we can reproduce those initial signs.
Thank you. And for Jennifer, this might be for you. What kinds of food will be sent up on this mission, and any special holiday foods?
Ooh, I love to talk about food. So before they launch, each crew member has the opportunity to work with the food lab to create their own menu. And the astronauts get to pick from a list of items that, include anything that's already been flown or anything that is on the menu from previous flights, but also things that they like and special requests. So for this mission, we've got some fresh apples and oranges and lemons going up, because the astronauts really don't get an opportunity to eat fresh fruits and vegetables while they're in space. There's also going to be some prepared foods for the holiday season, including fixings for a turkey dinner and some fun desserts. So stay tuned for pictures from that.
Thanks, Jennifer. Our next question comes from Twitter. And remember, you can ask questions on Twitter using the hashtag AskNASA. And it is for Brock here in the room with me. How long will it take to install the new doorway to space?
Okay, so the operation, once we get on orbit, again, it's all robotically controlled. It will take roughly a week to get the airlock out and fully commissioned and opened up for operations. Now, a lot of that is leak check. So it will take about a day for the robotic arm to grapple the airlock, maneuver it over to node 3, and berth it to node 3. Now, the next critical part is actually the leak checks. Since we're a brand new module, we want to tread carefully here, right, to ensure crew safety. So we will spend several days worth of leak checks to ensure that the airlock is leak sound and that we'll have it present no danger to the crew. And then after that, the crew will open the hatch and they'll be able to transfer into and then finish the commissioning of the airlock. So roughly about a week before we're fully up and running, ready to do science on board the airlock.
Thank you. Our next question comes from Twitter. And for Pinar, will this be the first time you send organoids to space?
Actually, this is our second mission. So we already flew a payload on CRS-18, I think. And this is actually one of the reasons why we're sending a second payload now. It's first of all to see if we can reproduce the results from the initial mission. Unfortunately, I'm not able to share a lot of the results yet because they're not published yet, and we also want to make sure that what we are seeing is reproducible before we can share anything. But yes, so this is our second mission, and we are now able to accommodate more samples with upgraded version of our Cube Lab, which I have not mentioned before, but for this project, we actually partnered with a company called Space Tango, and they're a company who are specialized in building custom-built Cube Labs. So these are basically shoebox-sized devices that are able to miniaturize our whole tissue culture room into a shoebox-sized device called the Cube Lab. And so right now, from the previous mission, we are able to have a better imaging capacities, and also, as I was mentioning, more samples. So we are very excited to be able to test all this and see if we can actually reproduce our results.
Thank you. And our next question comes from Twitter again. It's for Jennifer. I saw the crew is harvesting radishes right now. What else is the crew looking to harvest?
Ooh, that's another good question. So the crew is actually starting up another crop of radishes in the advanced plat habitat. Having more samples helps us get better science. So a second crop is being activated right now and should be done in about a month. The radishes are going to be sent back to Earth so our researchers can study them later in 2021. Something else to look out for maybe in the coming year are things that are going to be up for harvest a little bit later. So an array of plants such as red romaine lettuce and wasabi mustard and red Russian kale. Our Japanese counterparts are also growing some Asian herbs in space. I think it's a special kind of basil, so be on the lookout for those things as well.
I have a follow-up to that question, Jennifer, and it comes from Twitter too. Does the food grown on the space station have the same nutritional value as it does on Earth?
Well, that's a really great question, and actually, that's one of the reasons why we grow plants on the ISS is to do that, to study whether or not that nutritional content is the same or better. We're still waiting results, and some of the results have been published, but that's exactly what we're trying to figure out, is if the nutritional content is the same or different.
Thanks, Jennifer. And Brock, back to you here in the room. We have a question from our virtual NASA social Facebook page, and they want to know a little more about the robotic arm.
Okay, we're talking, just to clarify a little bit, the robotic arm used by ISS or?
Nanoracks Bishop Airlock.
Okay, so for the future.
Yep.
Okay, so one of the really cool things is being a commercial venture. One of our very first payloads for the Airlock is actually going to be a commercial payload. It'll be what we call a technology demonstration payload of a robotic arm. Hosted by our customer Gitai, who's out of Japan. They're going to do a technology demonstration inside the airlock, actually when it's berthed. So the airlock is being used not as an airlock per se, but rather a science platform to do experiments within the airlock. So Gitai is a really cool arm. It's done a lot of competitions down here on the Earth. They want to take it to microgravity and try it out as a technology demonstration. The goal eventually is that this robotic arm will be an aid to crew members that be able to work on experiments in space. So this arm is going to do things like plug in and out electrical connectors. It's going to screw in bolts. It's going to attach and assemble things that the crew would normally do, but in this instance, the robot would be able to do that, thus freeing the crew members up to have more time to do other science on board. So trying to maximize the science, if you will. So we're really excited about having them on board this summer inside the airlock and really doing some cool science on board.
So speaking of maximizing the science, one thing that I think is so cool about Bishop is that it's not just an airlock. It does host experiments inside and out. So right there on the model that he showed earlier, those little blue parts, they can actually host experiments outside of the airlock, which is really fun. So our next question is for Pinar. The question's from Facebook. And how long will the experiment last for?
Okay, so for this experiment, And also the last one was also this same duration. We're gonna stay in the ISS for 30 days. But eventually, in our hopefully next missions, we would like to also have longer periods of time to see what will be the effect of that on these brain organoids and their development.
I was going to ask, how long do the organoids survive for? How long can they survive for? That was another question that we got.
So these brain organoids in the lab, we are able to keep them in culture for up to more than a year, 2 years. So we are feeding them every couple of days, and with proper care, they are able to survive for a very long time, actually.
Awesome. Heading back over to Jennifer, we have a question from Twitter. What types of health issues can astronauts experience in microgravity on the station, and what research are you doing to prevent that?
Well, fortunately, our astronauts are very healthy, fit individuals, and they stay healthy in space. Of course, microgravity can have some negative impacts on certain aspects of their physiology, including their bone and muscle loss. And in order to keep astronauts healthy and strong during their mission, they exercise 2 hours every day, aerobic and strength training, and they have an optimized diet. We do have science experiments on board that study the effects of microgravity on astronaut physiology, such as ocular tests and blood tests and fluid shifts. So we have various investigations on board that are in support of the human research program we have here at NASA. But a lot of those activities are mitigated by what I said previously, lots and lots of exercise, lots of rest, and a wonderful diet.
Thanks, Jennifer. And our last question is back to Brock here in the room. What is the most unique challenge you ran into while designing and building Bishop?
So so another good question. So when we started this about 5 years ago, we kind of had a clean sheet of paper, and Nanoracks had the kind of the audacity to say, why don't we go build our own airlock? Well, a lot of that was we were a small company at the time, again, trying to so at the time we were trying to build reputation and expand our capabilities. We had never built an airlock before, right? So it's a challenge to build the team, to be able to convince NASA. It took us about a year to convince NASA that we could build the airlock on our own, and that we could fund it, and to have the technology and have the engineering team and the test team to be able to make that happen. We collaborated with a lot of partners that I mentioned earlier, and just so that was probably the biggest challenge, just getting everybody on board with the airlock itself. And now here we are 5 years later. And it's really a pretty cool testimony to be able to work as a teamwork, NASA embracing us in the commercial atmosphere there, and they have the faith in us to be able to make that leap and go on to building an airlock. We look forward to using the airlock on board, but it's really a stepping stone to commercial space stations, and we're planning on going forward even more. This is not a stopping point. This is a stepping stone to going forward, so we're looking forward to future space stations commercialized.
Thanks, Brock. And thank you, Jennifer and Pinar. And thank you to everyone in our NASA Social Facebook group who's been following along. I know there was over 10,000 participants in that group, so thanks so much for joining us. And for more on these research payloads and others, visit nasa.gov/ISS-science. CRS-21 is targeted to lift off tomorrow at 11:39 a.m. Eastern Time, just a few miles behind me here at Kennedy off of Launch Complex 39A. And tune in. Launch is at 11:39, but we are beginning live launch coverage at 11:15 a.m. and you can view that by going to nasa.gov/live. Thank you, and go CRS-21.